Welcome to science class. Today we're going to learn about sedimentary rocks. Sedimentary rocks are the products of weathering and erosion. Earth's surface is constantly being worn down, flattened, cut away, broken, or just blown around. A lot of this material ends up in the ocean, but most of it remains on land, where it is reincorporated into new rock formations. When you think of the American Southwest, that should conjure up images of red-painted deserts and striking rock formations, such as those found in Arches National Park. These are sedimentary rock formations. The dead giveaway is usually the layers of alternating color or depth. These layers tell an amazing story. They reveal to us coral reefs that are hundreds of millions of years old and a mile above sea level today, vast stretches of inland sea now dried up, volcanic ash deposits, petrified deserts, ancient riverbeds, and of course, the entire fossil record. Let's get started. Sedimentary rocks are the products of pre-existing rocks. The first thing I want to cover is how sedimentary rocks are formed. Every stone, every canyon, every mountain, great or small, is inexorably chiseled away to sand and dust, which we call sediment. The process of breaking down rock grains into sediment is known as weathering. Wind, water, ice, gravity, even living organisms are the forces behind weathering. Now, when I say wind and water break down rock, I really mean the already present sand, which is blown by the wind, breaks the rock down, and the mild acidity of water dissolves the minerals in the rock away. Water becomes acidic by absorbing carbon dioxide and sulfur compounds in the air. Any rock can become a sedimentary rock, and because the forces of weathering are nearly constant everywhere, sedimentary rocks are the most widely distributed rocks on Earth's surface. 75% of the surface is sedimentary rocks. In the last video, I said granite is the most common rock on the planet. That's still true. Keep in mind, Earth's lithosphere is on average 40 kilometers thick, but can be as much as 140 kilometers thick. That much volume is going to produce mostly igneous rocks, and deep beneath the surface, obviously sedimentary rocks cannot form. Erosion is the next step in producing sedimentary rocks. Erosion is simply the movement of sediments, and once again, wind, water, ice, and gravity are the agents of this process. Eventually, these sediments are deposited and begin to pile up. The pressure that builds up with this is an important step. Take a look at these sand dunes in Namibia. Some of them are absolutely gigantic. Why do these vast seas of sand dunes not produce, sandstone? Well, to be clear, they do, albeit very slowly. The final piece of producing sedimentary rocks is missing, which you probably guessed is water. A little bit ago I said water weathers and erodes rocks. Now I'm telling you it also helps make sedimentary rocks. Water, when it is in motion, will dissolve and carry away minerals, but when water is still, it can grow minerals. Water is an amazing solvent, and so it carries with it the ingredients to form minerals out of precipitation reactions. As these layers of sediments are compacted, the water is exuded, but the minerals stay behind. With the water gone, the minerals begin to crystallize on the surface of the microscopic sediments that are all around. Eventually, these minerals grow into one another at any and all orientations, and the loose sediments are bonded together. We call this lithification. Quartz, feldspar, and calcite are some of the more common minerals that cement sediments together. Sedimentary rocks that are formed from pre-existing rocks that have been weathered, eroded, compacted, and cemented or lithified together are what we call clastic sedimentary rocks. Geologists further classify clastic sedimentary rocks by the average size of their sediments. Conglomerates and breccias are each made of mineral grains that are at least 2 millimeters in diameter. Conglomerates are made of smooth pebbles, while breccia is made of more angular fragments of rock. Sandstone rocks are made of mineral fragments that are less than 2 millimeters in diameter, but greater than 1/16 of a millimeter. Mud rocks have the finest texture to them. Siltstone mud rocks have a texture a little bit like tile. It's not glassy smooth, but you could hardly call it abrasive. Shale, which is compressed mud, is the finest texture. It's made of mineral grains less than 1/256th of a millimeter across. However, shale and mudrock can also be used interchangeably. We don't have nearly as many names for sedimentary rocks as we do igneous rocks because a sedimentary rock can be made out of anything. They're not formed from a single unique parent material. Sedimentary rocks will often be a hodgepodge of so many different minerals that there's really no sense in classifying them by what's most common the way we did with igneous rocks. So we just classify them based on their texture. There is another group of sedimentary rocks, however. These are the chemical sedimentary rocks. Any fossil that isn't trapped in amber or the frozen remains of something is almost guaranteed to be a chemical sedimentary rock. Limestone is also a chemical sedimentary rock. Limestone is actually made from the calcium carbonate minerals deposited by marine organisms such as radiolaria, foraminifera, and coral reefs. Flint, a variation of a sedimentary rock called chert, also the favored rock by hunter-gatherers for making arrowheads and blades, also forms this way. These rocks are also referred to as biochemical rocks because they form from the remains of living things. Coal and oil shale are also classified as biochemical rocks. What makes chemical sedimentary rocks different is that they form as the minerals precipitate in the presence of water rather than as water is removed like clastic sedimentary rocks. I need to add to this because chemical sedimentary rocks, the minerals within them form from precipitation reactions, meaning they form as the water evaporates away. There's no bonding together of sediments. Instead, the entire body of rock is formed from minerals present in the water. This isn't exactly the case with coal and oil shale, but we'll worry about them another day. Volcanic ash can also be compacted into a rock called tuff. This is considered a sedimentary rock because it is layered and compacted. The amazing fossil site called Ashfall Fossil Bed in Antelope County, Nebraska, perfectly encases these massive animals from an eruption by our old friend the Yellowstone supervolcano 10 to 12 million years ago. And I'm sure you've heard of Pompeii, the city and its people destroyed, but also ghastly and somehow still wonderfully preserved. That culprit was Vesuvius, and the eruption occurred in 79 AD. Now, sedimentary rocks can tell us more about Earth's past than any other kind of rock. The processes of weathering, erosion, deposition, compaction, and lithification occur very slowly but constantly. Because this process is constant, it can build up and preserve huge spans of geologic time. We looked at the cliffs of Zion Canyon last week. Those are half a mile tall and represent around 160 million years of deposition. The Grand Canyon is almost a mile deep in places and represents over 250 million years of deposition. Obviously, environments in one area change over millions of years. The ground you're standing on may have once been underwater, covered in glaciers, a vast stretch of tropical swamp, you name it. An area that is underwater, for example, will have vastly different physical and chemical processes at work compared to a desert or grassland or forest. Completely different types of minerals form in these varying conditions because the chemistry when you are underwater is very different from dry land. Those differences can be seen in the sedimentary rock layers, which we call strata. Looking at this picture, you can see that this particular area in the distant past went through all kinds of periods of unrest. There are yellows and reds and tans and whites and even green layers deposited throughout. Then a period of relative stability takes over in the top half of the section. We know that because the layers are much deeper and consistent. In many places around the world, you can see how that particular area has undergone massive changes over time. In Badlands National Park in South Dakota, there are several alternating layers of unique colors and mineralogy. The lowest and therefore oldest layers of the park form what's called the Pier Shale. Again, shale is compressed mud. This layer formed during the age of the dinosaurs, when the interior of North America was underwater. This was called the Western Interior Seaway. While one of the most famous fossils in the world, Sue, the largest and most complete Tyrannosaurus rex ever found, was found in western South Dakota, fossilized mosasaurs and seashells are what you find in the Badlands, at least in the layers older than 66 million years old, that is. Above the Pierce Shale are the so-called yellow mounds. This layer was deposited when the area dried up. The formation of the Rocky Mountains also uplifted the interior of the continent, causing the western interior seaway to drain away. The yellow mounds are what is known as a paleosol, petrified soil. The reason that only this layer is yellow is because the mud that made up the bottom of the seaway dried up and chemically reacted with the air. Obviously, this could only continue for a short time since the sea never came back. So this layer is relatively thin. Above the yellow mounds is the Shadron Formation, which formed as rivers flooded the area, depositing their sediments over a span of around 3 million years. Above this layer are alternating layers representing grasslands and volcanic ash deposits of all things. Like the Pierce Shale, a rich source of fossils are found in these layers. Today, the kinds of large animals that live in this area are mammals, and they include bison, pronghorn, bighorn sheep, white-tailed deer, coyotes, and not much else. The fossil animals you find in these layers, however, include crocodiles, horses, entelodonts, which were like pigs, brontotheres, gigantic relatives of rhinos, and camels. These rock layers span from 29 to 37 million years ago. And that long ago, yeah, those were the kinds of animals living in North America. Not too far away in Hot Springs, South Dakota, is the famous Mammoth Site, a geologically preserved sinkhole where 61 mammoth skeletons have been found alongside bears, oxen, camels, llamas, wolves, coyotes, and more. See, sedimentary rocks also preserve the rich and dynamic transitions that life has undergone on the planet. Next time we're going to learn about metamorphic rocks and the rock cycle. Thanks for watching.